Hello, this is Vivian Chan. In this video, I'm going to explain HSC 2018 Mathematics Extension to question number 11. Question A. It is a question about complex number. The question provides two complex numbers C and W. In the first part, the question asks to find the product of these two complex numbers. In the second part, the question asks to get the conjugate of C and minus 2 over W. Multiplication of complex number. Real part multiplied by real part equals to 2, and imaginary part 3i multiplied by minus I is 3, because I times I is minus 1, and the minus 1 and this minus become plus. And then the real part multiplied the complex part, we have 2 times minus I is minus 2i, and 3i times 1 is 3i. Minus 2i plus 3i makes it I, and therefore the product is 5 plus I. Part 2. Conjugate of z equals to 2 minus 3i. Conjugate of a complex number, if it is a plus, we change it to minus. The other way around. If it is minus, we change it to plus. For the complex number 2 over w, since the w is in the denominator, we try to separate the real part and the imaginary part by multiplying the conjugate of w to both the numerator and the denominator. 1 minus I times the conjugate 1 plus I become 2. And the 2 and 2 can cancel each other from the numerator and the denominator, and we have minus 1 plus I. After expanding this bracket, we have minus 1 and minus I. Eventually, the answer is 1 minus 4i. In part B, the question introduced a degree 3 polynomial px in the form of x cubed plus ax squared plus b. And the question tells you that this polynomial has a 0 at r and a double 0 at 4. By all these information, we know that px can also be expressed in the form of x minus r times x minus 4 to the power 2, a 0 at r and a double 0 at 4. Expanding the polynomial on the right-hand side, we will have the multiplication of x minus r times x squared minus 8x plus 16. By grouping the coefficient of x cubed, x squared, x, and constant term, we will have this polynomial. This is the polynomial provided by the question. And these two polynomials, they both represent px. They must be exactly the same, means x cubed coefficient should be equals to x cubed coefficient, x squared coefficient a should be equals to the x squared coefficient minus the sum of r plus 8. And the x coefficient, there's nothing, means 16 plus 8r should be equal to 0. Constant term minus 16r should be equals to b. From the equation in the middle, we know that r equals to minus 2. Then we can get the value of a equal to minus 6 and the value of b equals to 32. Part C asks you to write this rational polynomial in the form of this one and then do the integration. These two rational polynomials, they are only in different forms. Therefore, we can put a equal sign to the two different forms. On the right-hand side, we try to add these two together. For the first term, you multiply x squared minus 3 to the denominator. Of course, you have to multiply the same thing to the numerator. Same to the second part, you multiply x plus 1 to the denominator, and you have to multiply the same x plus 1 to the numerator. And then expand the numerator, we collect the x squared coefficient. The ax squared plus the bx times x, you get a plus bx squared. To collect the coefficient of x, we have bx times 1 and c times x. So coefficient of x is b plus c. And the constant term, we have minus 3 times a and c times 1. Since these two, they should be exactly the same, Therefore, we can conclude that A plus B is actually equal to 1. B plus C equals to minus 1. C minus 3A equals to minus 6. Now we form 3 equations with 3 unknowns A, B, C. To solve this system of linear equations, we can change it to this form. A plus B, no C equals to 1, first equation. No A, B plus C equal to minus 1, B plus C equal to minus 1, and then minus 3A, no B but plus C equals to minus 6 is the third equation. And then we use the first row times 3, add it back to the third row, and then we will have the third row changed to 0, 3, 1, and then minus 3. And then use the second row times minus 3, add back to the third row, we will have 0, 0, minus 2, and 0. So from this row echelon form, we know that minus 2 times C equal to 0, which gives you C equals to 0. And then B plus C equals to minus 1. Since C is 0, so it gives you B equals to minus 1. And then A plus B equals to 1. Since B equals to minus 1, it gives you A equals to 2. Now we can conclude that this rational polynomial should be equals to 2 over x plus 1 minus x over x squared minus 3. The question asks to do the integration of this rational polynomial, and by equivalence, we can do the integration of the right-hand side. So integration of this polynomial is actually equals to the integration of the difference of these two rational polynomials. Integration of 2 over x plus 1 is simple. We know that it equals to 2 log x plus 1. But integration of the second part, x over x squared minus 3, this one is tricky. But we know that dx squared minus 3 equals to 2x dx. We have x dx. Therefore, if we multiply 2 and divide 2 at the same time, we can change this 2x dx into dx squared minus 3. And so now we know how to do this integration. It is minus 1 over 2 log x squared minus 3 plus c. Question D gives you points A, B, C on the Argand diagram. And this A, B, C represents complex number U, V, and W with U equals to 5 plus 2i. The question asks you to find out the value of W and V. Since ABCO is a square, and we know that U, after the rotation of an angle pi over 2, it goes to W. Therefore, W should be equals to I times U. We also know that U plus W goes to V. Therefore, V should be equals to U plus W. Now, problem solved. W equals to I times U. So we multiply the complex number U by I. We will have this minus 2 plus 5i. V equals to U plus W. So this is U, this is W, and V equal to 3 plus 7i. Question 3 asks you to find the argument of W over V, and it is equivalent to find the argument of W minus the argument of V. We know that by rotation of U by the angle of pi over 2, it goes to W. Therefore, if the argument of U is theta, then the argument of W should be equal to pi over 2 plus theta. How about the argument of V? By the property of a square, we know that BOA should be pi over 4. Therefore, the argument of V should be pi over 4 plus theta. Now we know that the argument of W minus the argument of V should be equals to pi over 4. Question E. There is a circle with center O and the radius of this circle equals to R. On the circle, there are 2 points C and D. Chord AC equals to D. The question asks you to show that D is actually equals to 2R sine D. But we know that this angle D is actually equals to angle ABC. As AB is a diameter, therefore we also know that this ACB is a right angle. Let's now take a look at this triangle ACB. Right angle. Sine angle B should be equals to AC over AB. Therefore, we can write down sine B is actually equal to D over AB. It is a diameter, which is 2R. Therefore, D is actually equal to 2R sine B. But we also know that angle B should be equal to angle D because they are angles come from the same arc, AC. AC sustains angle B, it also sustains angle D. So reason is equal arc equal angle. Therefore, we can conclude that D is actually equal to 2R sine D.